Hi there, my name is Lars. Great that you're watching this video. We're going to inspire you with some of the stuff that's going on at CVC 2019 here in Las Vegas. And at the Computer Vision Conference, we're seeing all these amazing angles of research being presented all around computer vision. And our next guest is also one of our submitters of a paper. And we're very glad that he's here. It's Dr. Xianping Li from the University of Missouri, Kansas City. Great to have you with us.
Thanks.
First of all, what brought you to our conference? Why did you choose CVC?
I'm an applied mathematician, and my research relates to apply the mathematical methods to different fields. One of the applications in image processing, and I think computer vision conference is a good fit for one of the papers. So. Yeah.
And how are you enjoying it so far? Inspiration, interaction, do you like it?
I enjoyed it very much so far. I enjoyed chairing the 3 sessions and enjoyed listening to different representation of different topics, and I learned a lot from different people.
That's always great to hear. Yeah. I think the learning is in meeting all those different bright minds and learning from them. You yourself are also bright minds. Can you share us a little bit about how you're using the image processing from the mathematic angle? Yeah.
Okay. So as mentioned, I'm a applied mathematician with expertise in computational mathematics. So my research focuses on developing computational methods to all kinds of problems arising from other fields such as biology and physics and image processing. So we can perform image segmentation by just solving some differential equations that is derived from some functionals. Mm-hmm. So that's a basic idea for that. So with this, we don't need a lot of images to train, or we don't need other previous information about this object. Just give me one image and I solve a differential equation and get a result.
But wouldn't there be like a big fault margin on that you'd say, okay, what if the image is crooked?
Yes, so depending on the quality of the image, but yeah, there are a lot of things to work with this also, yeah. But that's a fun part of research.
Yeah, I can imagine. So in this particular piece of research, what kind of specific problems did you address?
For this one, this is a starting point for our research. So now we want to focus on the white matter segmentation in brain MR images, because it's very important to know the accurate volume of the white matter in the brain, so the doctors can diagnose some important information. So there are some existing software packages that can do that, such as SPM, FSL, FreeSurfer, and many people and the doctors are using those. Mm-hmm. So our question is, okay, which one does the job best?
Yeah.
So I'm advise the students to look into these software packages and run the simulations and use some quantitative metrics to compare the results from the different software packages, and then we can select the one which works best for white matter segmentation.
And are these results, do they align with the thoughts that you might have at front?
Yes. Yeah, we had interesting and very useful results, and so that's a starting point. And the next step, again, as an applied mathematician, I would like to apply our mathematical methods to do segmentation. Hopefully we can do better than those software packages.
So as you're being at the conference and presenting, and so people will come with questions, you had some questions that maybe even triggered you to think on evaluating your work.
Yeah, some people ask the questions already. Say, like brain MR image segmentation is kind of like a well-defined area, and many people are already working on these areas, and still, I mean, as I can see, there are still many researches going on also. Even those existing software packages, they are still developing and updating once a few years. So as long as we have new methods come from mathematics point of view, and I think it's good to apply to this to see if we can do better.
Okay. Yeah, and I always hope that there are questions or critical, because that only gives you an opportunity to keep on with your research.
Yes.
So we understand that it would be great to have more explanation on your research, but we have to keep these interviews a little bit short. So I want to apologize for that.
No problem.
Thank you so much for sharing your thoughts and give us a little bit of an idea. And hopefully it triggers you to dive into the research. All of the submitted papers will be also be available online later on. So it gives you the chance to see all the work of Xianping Li and the University of Missouri, Kansas City, and your team to dive into that. So if you want to see more videos, please hit the subscribe button on our channel. We'll make them all available to you. And obviously you could share this one with your friends. Thank you so much for watching this video, and hopefully we'll see you in the next.